This short video will help with how to machine a brake drum. So the first step in machining a brake drum is inspection. So we're going to inspect that this drum is in good repair, that it is possible to put it back into service. The first step in doing that would be taking measurements. We're going to use our drum gauge here to take a measurement across the diameter of this drum. Now it's important when taking this measurement that we get to the widest portion of the drum. A little wiggle side to side will help you to get to the widest portion. It's important though to remember that we need to keep this drum gauge level as well. So if we're level, going down will get looser, turning it up will also get looser. If it gets tighter, we're not at that center point yet. So first step, a measurement here. If we want to know if this drum is tapered or bell-shaped, we're going to take a measurement towards the top of the drum and then record our specifications, then move further down deeper into the drum and take another measurement. That will tell us that if these numbers are dissimilar, if they're not alike, that we have either a tapered or bell condition on the drum. So record your measurements. To determine if this drum is out of round, take a measurement at 90 degrees to your first measurement. If the numbers are the same, the drum is round. If the numbers are different, we have an out of round condition. We can do the same step by taking multiple measurements at multiple points around the drum to determine if we have an out of round condition. Once we've determined that, we take our numbers and compare it to specifications. Now, if we're fortunate enough to have the specifications, the maximum drum diameter written on the drum, we can use this number. If not, we have to consult the service manual. At this point, we need to make sure that the hub surface of our drum is clean enough so that our drum will sit flat on our hub adapters. You'll notice that I've begun to clean up part of this surface, but we need to finish it up to make sure that we have no corrosion here, changing the angle at which the drum will sit. So we're going to take our die grinder and perform that now. This surface is good. We're going to spin to the inside. Always remember to wear safety glasses. Be careful when using a die grinder, and it would even be advisable to wear a dust mask if it's severely corroded. At this point, once I've cleaned the drum, I've compared my specifications, and I know that I have enough material left that I can safely machine this drum. I'm ready to set up my brake lathe. So come over here to my brake lathe. Step number one is selecting the right sized hub adapter. We're looking for the right adapter that will keep this drum centered on our lathe spindle. Below, we need to get our hub adapters. We have a number of different size hub adapters, and so we're going to select the right size adapter that leaves us enough room to be able to get our cutting tip inside of that drum. So they come in pairs. We're going to start with one adapter. First adapter goes on. Our centering cone needs to be spring loaded, so make sure the spring goes on after the first adapter. You'll notice that the spring fits perfectly into that cone. That lets you know the direction in which the spring should be mounted. Following that, we can now mount our drum. We're going to hold on the drum with the matching pair to the first hub adapter. At this point, we need to have a little bit of a spacer. We haven't reached the end of the spindle where there's threads, so we're going to put on a spacer. I always like to include this spacer because it's a balancer. What this does is it helps to keep the vibrations down and reduce the tip from bouncing on the drum, which will cause a bad finish. At this point, I still need another spacer, so I'm going to select the right size one that will get me to my threads. When I'm mounting on my spindle nut, I need to keep in mind it is a left-hand thread. It's a left-hand thread so that the drum will not loosen off when machining. It's a little bit counterintuitive, but once we've got it started, we're all set. Our tool, tighten it up. Doesn't need to be incredibly tight, but tight enough that it won't come loose. At this point, we need to also try to reduce the vibrations even further. So what we're going to do is we're going to put on this vibration dampening belt. We want to try and get it fairly snug onto the drum. And be aware that it can be a little bit cumbersome at times to get this belt on. Nice and tight, and then just clamps back into itself. All set. Now we're going to set up our machine. First things we need to do is make sure that in the position in which our cutting tip is laid out right now, that we'll be able to reach all the way to the inside of the drum and all the way to the outside of the drum. If we can't do that, we don't want to find out halfway through our machining process. This dial moves our cutting table left and right, and this dial will turn our cutting tip in and out. So let's move this all the way in. Make sure that we can reach all the way into the inside of the drum. Excellent, I can do that. So at this point, I'm happy with my positioning, and I'm going to begin a scratch test. A scratch test will help me to see whether or not my drum is mounted straight. What I'm going to do here is very carefully, with my light mounted in the right direction, I'm going to see if my cutting tip will contact all the way around or only part of the way around. So go ever so carefully and bring your cutting tip in until it just contacts the drum. And as you can hear, the tip is not making full contact. Once I shut off the machine, I can see that my cutting tip has only cut part way around this drum. We'll get a little closer and have a look at that. So as you can see my scratch test, it has scratched in this area here, but on the other side of the drum, there's no contact whatsoever. Two conditions can cause this. Either the drum is out of round, or I've mounted it improperly. So I'm going to check which one of that it is. I'm going to loosen off my spindle nut. I'm going to rotate the drum. Spin your dial in first. Rotate the drum 180 degrees. Once you've done that, tighten the spindle nut. Reposition your tip into a new spot. And once again, bring it out nice and slow. We just want to touch the drum. Now I'm going to compare my two scratch cuts. If they're both on the same side of the drum, that tells me that the drum is out of round. If my scratch has now moved to the opposite side of the drum, this tells me that I do not have my drum straight, and therefore I'm going to need to realign things. Perhaps I need to clean it up, or perhaps I have some corrosion between the two mounting surfaces. At this point, I can see that both of my scratches are parallel, they're right beside each other, so I have some run out in the drum. But that's okay. That's part of the reason we want to machine this drum. We're going to cut that out. So now, I'm going to start my machine up again. Our switch here down at the bottom. I'm just touching the drum, so I'm going to use this as my 0 point. I'm going to turn the inner dial while holding the outer part of the dial, and I'm going to set this to 0. This is my 0 point. I'm going to bring in my cutting tip all the way to the inside of the drum at this point. Being very careful that I do not cut into the outer hub. I'm going to begin now to take off more material. I'm at my 0 point. I can take up to 10 thou per cut, so 10 thousandths of an inch. This drum is in reasonably good condition, and I don't want to take off that much material, so I'm going to take off 6 thousandths of an inch. On this specific machine, it's important to know that each line is worth 2 thousandths of an inch, not 1 thousandth of an inch. Now I've set it for 6 thousandths of an inch on the dial. I'm going to secure my setting by tightening up the knob here. Now I have two options. I can either perform a rough cut or a fine cut. Because this is my first cut, I do have some deep grooves, I do have some corrosion or some rust, I'm going to perform a rough cut first. So I'm going to pull out, lift up the knob, and it's going to begin to engage. You'll notice that the cutting tip stops contacting for just a brief second there. That was because I have a deep groove in my drum. I'm hoping to machine that out. At this point, I've completed my rough cut. I'm now going to inspect my drum and see if I have any corrosion or deep grooves left. At this point, I have basically eliminated all of the corrosion, and I'm happy with that finish. However, I still have that one deep groove. That tells me that I'm going to need to do another rough cut. How do I do that? Put my machine back into neutral. Also be careful I don't have my light touching the drum before I start it again. It will break the light. Start it up, and now I'm going to drive it all the way back into the last position I started. Once again, I need to take another rough cut, so I'm going to do another 1/6 thou. I'm going to turn this up to 12 thousandths of an inch. Rough cut, so the upper position on that sleever will take me to the rough finish. If you hear a ringing noise while you're doing this machining, that tells you that you're having too much vibration. The vibration will cause a rough finish, and it's not what we want to accomplish with our machining. Now we can wait for the machine to stop, or we can shut it off ourselves at this point. Now I've eliminated that deep groove in there. I'm ready for a fine cut. A fine cut is accomplished the same way. Start up your machine. Once it's in neutral, you can now dial it in manually. Once again, go back to your starting point, all the way to the outside edge without hitting the hub. And now we can take off between 4 to 6 thousandths of an inch. I'm all set, but now I'm going to pull the lever and go down to the fine cut. I'm going to go down, and you're going to see that by the label on here. Up is rough, down is fine. It's going to cut a little bit slower. Now that we've done our fine cut, we want to examine the finish of the drum. So the easiest way to do that, grab onto the drum, use a fingernail. We shouldn't have any deep grooves on there. If we do, we want to finish another cut, do another fine cut on it to remove those grooves. This is an important thing to remember. Why is that important? I'm going to show you here this drum brake setup we have here. When we've cut that drum, basically we've cut a long line all the way around that drum, just like a nut. Now, that nut that we've just made would be spinning around on our hub. As it's spinning around, we then apply our brakes. When we apply our brakes shoes are going to want to follow that groove, that threading. If they do, once we've finished our brake job, these shoes will tend to want to follow it and then release. Follow it and release. And so we're going to get an undesirable noise going on in the back of our fresh brake job. We don't want that. So what do we have to do? We have to remove that directional finish. So bring your lathe out of the way. If you're happy with your cut, you finished your last cut, draw it out of the way because you're going to have your hand in here and you don't want to get it caught. So now I draw both portions of it out of the way. I'm going to take a piece of sandpaper, coarse grit sandpaper. And at this point, I'm going to try and remove that directional finish. So I'm going to go hold this sandpaper on here and slide it back and forth, being very careful with what I'm doing. Nice firm pressure, back and forth. What that does is cancels out or takes off those lines that I've cut into there with my cutting tip. The sharper the tip, the better finish we'll get. Once again, put your tools away as you take them off. Left-hand thread nut, spacer, harmonic dampener, hub adapter down below, our vibration dampening belt. I'm going to roll it up nicely and put it down below the machine. And now, my drum. If at this portion I've done a fine job, I can expect to put this back into service and have a nice, quiet brake application. One step before I put it back into service, I need to measure. So I'm going to take my drum gauge once again, and I'm going to measure and determine if it's still within service specifications or if it's oversized. If it's oversized, there's nothing we can do. It must be replaced. If you're happy with the finish, you're now completed and this drum can go back in service. So that's a little video on how to machine a brake drum.